Okay, so
Which method?
which method? Great, so we're differentiating. And Harry's asked, which method do we use? What have I told you in a situation like this? What can we do? Well, yeah, if we have two functions divided by each other, the quotient rule is a great way to start, right? So how do we start off? Using our usual ways, we let u equal to our numerator function, so 4x to the power 4 plus x cubed. And what would v be?
X squared.
X squared. So let's take the derivatives there. Sorry?
Oh, no, never mind. You told me.
Okay. And then v dash and u dash, that's what we need. Because remember, at the end of the day, our derivative function, we're getting y dash is equal to vu dash minus uv dash all over v squared. That's what we're looking for here, right? So u dash here, James, what am I going to do?
That would be 16x to the power of 3.
Yep, so we drop this power down and multiply by a coefficient, so 16x cubed.
Plus 3x to the squared.
Plus 3x to the squared, yeah, that's right. Angus, what if I differentiate v here, x squared? What's that? That'll become 2x. Once you have these, right, that's why I love this structure. We put all these pieces together, and we're going to say we've got the u dash. So I've got x squared outside of 16x cubed plus 3x squared. So we've got v dash, so we've got something really long here. 4x to the power 4 plus x cubed, right? All over, what's v squared? So x to the power 2 all squared. Pretty long expression, right? What have I said when we get something like this? Well, yeah, like, when we go back to junior school, we've been asked to simplify so many times. So let's do that here, right? We simplify, we expand this all out. Powers, remember, if we multiply them at the same base, we're summing those indices, right? So we're multiplying these two here, we're summing these indices here, so 2 and 3. So 16x to the power 5 plus, what do I get here?
3x to the power of 4.
Cool. With these negatives, be careful. It applies to this whole bracket here, right? So over here, I'm going to be getting 8x to the power 5. And then because this negative applies to this coefficient here, this is also going to be negative when I expand it out. Yeah, minus 2x to the power 4. All over, what happens when I have a power to the raised to the power? So we multiply them and we get 4. Okay, I think it's going to actually simplify quite nicely, right?
Yeah.
What can I simplify through?
Subtract the 8x from the 16x.
So we get 8x to the power 5, awesome.
And then x4.
X to the power 4, so positive, yeah. And
Are we done yet?
are we done yet?
No, you can do even more simplification.
What could we do?
The 8x plus 1.
You could strike out the x to the power of 4.
Yeah, so a few ways. If you're okay with seeing it straight from there, you can do that. If you're not too sure, like what you can think about is you're actually factorizing here, right? You're actually saying, look, what's in common with the numerator? Well, there's a factor of x to the power 4 here, right? What do you get left with if we take that out? 8x. And then here is just, yeah, plus 1. This x to the power 4 just divides through. Is our final answer, right? X plus 1 is our final answer, right? But when you look at this, what have I also said to you about using different rules and methods?
I forget. What have you said?
Like, do we think this is a quick way of doing something like this?
Oh, you could have simplified it.
Yeah, I think James has seen it, right? What could you have done over here?
You could have just done it from the start.
What could you have done from the start? Tell me.
X to the power of 2.
Or what we can do is, what do you want to take out?
X to the power of 2.
Alright, so we've got y equals to 4x to the power 4, x cubed, over x squared. And you take out x squared from the numerator. What do you get left with?
4x.
Yep. Plus all over. Hang on, this is starting to look very interesting. So we divide these through. And let's take the derivative now. So what do we get? 4x squared plus x. Oh, the answer. Hang on, that seems very familiar. We take the derivative here. We're going to get 8x plus 1. We bring this coefficient down, multiply it there, decrease this by 1. And you can see, like, that's why you want to think before you just start approaching a question, right? Don't just see this and say, oh, two functions multiplied, divided by together. I'm going to jump into quotient rule, right? Think, hang on. Okay, what am I actually trying to do? I'm trying to find derivatives. Is there anything I can simplify? Is there anything else I can do with that? Do you want to see one more?
us to see one more?
I want you to see one more. There's one more interesting one. And so, same idea. If I have a function, let's say y equals to 1 over 3x minus 2. I've got something like this. Students are looking at this and they see something divided by something, and really what they're looking for is they see a fraction and they're thinking, yeah, quotient rule. Let's do it. But before you do that, just think, is there another way I can rewrite this? And because we've got an expression like this, we know with our index laws that we can rewrite this another way. How can we rewrite it? Right, we want to use our knowledge of negative indices. I've got this expression in the denominator. If I rewrite it as 3x minus 2 all to the power negative 1, then I can say, okay, that's going to make my life a lot easier because that's just one application of chain rule, or function of a function rule, right? So our derivative is now, we drop the power down, keep our original expression the same, decrease the power by 1, multiply by the derivative of the inside expression, just 3, and so we've got minus 3 outside of 3x minus 2, all to the power negative 2. Again, if you'd like, you can continue going and write it like so. That might be one way that some people prefer, but both of these are perfectly correct. So again, just another little thing to be thinking about before when we've been taught the quotient rule. We want to think about all the tools we have available before we use it. Is there going to be a better way to approach this question?